Hello everyone. Thanks for subscribing my YouTube channel. Now in this course, we have new course here, and in this course we are going to learn about data center automation with help of Ansible. What I have done here, that I have uploaded the document, so you can see that giganetworkers.in. You can go here. Once you reach up to this place, then you can see that you have one section called other courses. You can go to other courses and you can see that we have one tab here, data center automation via Ansible. Now once you go inside this, you'll find that first of all you'll find the slides, data center automation via Ansible. And if you go and scroll down, so the two important things here you'll find. One is the document, other one is the video link as well. So first of all, if I scroll down, you can see here the slides. So you have all the slides. So while watching the video, you can go and refer these slides first of all. Second thing is that the script. So Ansible related all the scripts I have uploaded here. You can copy and you can use this script as it is as well in your environment, means in your lab environment, not in production. Test everything in the lab environment. If it is working good and fine, then you can go and use this inside the production. Correct. I already tested there these codes inside the lab, and you will watch all those programming coding inside the video inside this particular course. So I hope that this particular course will be informative for you, and you will learn something new that again you can utilize in your personal and your professional career as well. Hi everyone, welcome to ACI and Nexus Automation via Ansible course. In this particular course, you will learn the basics of Ansible, but those basics are not like Ansible programming basics, but basics with relation to Nexus and ACI automations. So you will get so many different links from where you can go and extract more information about the modules and the plugins related to say NXOS and the ACI. The overall purpose and goal of this particular course is that you understand how you can automate the Nexus and ACI. You can start your automation journey from this particular place. So I hope you will enjoy this particular course and you will learn new information and you will try to implement in the real life scenarios. Thank you. You can go to the following link and you will get the instruction that how you can install the Ansible. So let me log in to this particular site. Let me open this URL and let's see how we can install. No login required for this particular site, means you don't need username and password. Simply you can go and open the URL. Once you open that, you can see here that we have the installation guide. Inside that installation guide, you can see that we can install it over various Linux versions like Red Hat, Debian, CentOS, macOS, etc. It is very important to note that currently Ansible can be run from any machine with Python version 2.7 or 3.5 and higher installed. Windows isn't support for the control node. So any Linux machine who having the Python version more than 2.7 or 3.5, they can run the Ansible. There is no problem. And you can see here, say step by step, you can go and check for different Linux flavors like Fedora, uh, Red Hat, CentOS, all these things. You can see that how you can install it. So I can go, I can do sudo yum install Ansible, because in our workstation in our lab we have CentOS. The easiest way to install nowadays is to use the pip command. So let me go down and show you that pip command as well. You can see preferred way Ansible in the Mac OS is the pip command. So we can use pip pip to install it if we are using Mac OS. Most of the time people nowadays are using Mac OS, so you can install that with the pip command, no problem. Let me scroll down. So you can see other important informations as well. All right. Solaris and Arc and Slackware. So all these options are there. Just visit that particular URL and then you can see all those things. So since we are using the CentOS and already I have installed that Ansible, so we can go and use that. But anyways, let me show you that how you can go and install over CentOS. Mostly nowadays people are using macOS, so there also, even if other flavors are there, you can Fedora or other, you can see the installation, how you can install it. So here I am inside the CentOS. You can see the release, CentOS Linux version 7, CentOS Fedora core, like this, and how you can install Ansible, although it is already installed here, but we can use install Ansible. Okay, this is the way that you can go and install it. So while you are installing it, it's very important that you check the process and all. Transaction check succeed, running update. Now you can see that Python 2.7, the Ansible version also we can go and check, that is 2.4, the latest one. And what are the other things we have here, we can see. So if I go up, it is installing the package. If I scroll down, we can see the Python packages 2.4.1 and all the dependency and the requirements. Done. So now what I can do here, I can go and check Ansible and say version 2.4.2. we have the configuration file here, the configuration module, the location. You can see the user library Python 2.7 site package Ansible, and related information we have. Even if you want to know more about this, you can always go to Ansible and help, that you can go and check whatever parameters we have related to Ansible and other stuffs. And finally, if you want to run, you can go and run Ansible playbook and we can see the version. I should give playbook and the version. Alright, so we are running 2.4.0. How to install? It's very easy. You can go and refer the site, and once it is installed, then we can go and play around with this. In this example, we'll see that how from the Python program I can log into the Nexus, say for example Nexus 1 device. I can go to conf-t and then I can enable the feature, say feature NXAPI. Okay, so let me go to the empty putty that I have. Here you can see the program, user bin environment Python 2, and then you can see the comments as well in the blue color. So this comment is for SSH. Then pause the script, a list of the host. Suppose in this case we have only one host. Then what is the login credential for NXOS? So for example, username and password Ansible. Create a new SSH connection. Automatically add SSH host key for each host we wish to connect to. So this will be the output once you log into the once I run this program, then this print output will come. Create a shell session for multiple commands. So say with this connection.connect host 22 is the port for SSH, username, password. look for keys false, allow agent false, remote cell, connection invoke cell. So I'm going to create the cell connection for multiple sessions, and then you can see the output here is remote cell receive. That's okay, print the output. So it will print the output that is host. Then what type of commands that I want to run here? So first of all, send the command conft. So I'm going to run the command conft /n is the new line. Sleep for 1 second. Then the output will get the output like this from the remote cell. Then the second command I'm going to run is the enable feature NXAPI, that is a feature NXAPI. That will be the second command. Again, it will print the output for us once we run this Python script. Exit the configuration mode, then you can say end, exit, and then print the output. After that, close the SSH session to this particular host. We can reuse all these things, so no worries. What I can do, I can do here, press escape colon Q for quit, because what I want to do here, I want to run this program. You can see Python enable feature.cli. The print output you can see NXOS, then all these banner. What it is doing, say these are the outputs in the program. Conft, you can see the output, then the feature NXAPI output. That means now this particular device, if I go and log to this particular device, and if I see show feature, so for example, I want what are the features have been enabled. So enable, now you can see NXAPI has been enabled. And if I go and check, say for example, so NXAPI output, we can see the output for that. So NXAPI is enabled. It can be listen on these particular ports. Then even I can go and open via port 80 to this particular Nexus with the GUI mode. So this was the very small example, but later on we are going to add multiple use cases on that. In this section, I'm going to show you that how you can edit that program. So what is the end goal we have? That edit that Python program and add some lines. So while executing the program, I can check show NXAPI. Okay. So let me go and open the empty putty. All right. So we are inside the Ansible. Let me go and edit this particular program. So I can go to conft, then I can enable the feature, that's okay. And after that, what I want to do here, that I want to see that as well. So how I can do that, I can click insert because I want to add few lines here. And I can go here, first of all, I want to add comment. So for example, I want to show the NXAPI, say feature status. Then I can give the same thing that you can see this particular place, remote shell dot send, and what I want to send here is the show NXAPI end of the line. That will be the next line, and then close the parenthesis or the bracket. That's the common rule of the programming. Once you open some box or bracket, you have to close that as well. Then here I can give time sleep, say for example 1, complete programming or scripting type of things that we are doing at the moment. Output I can give, say for example, I can give a space here, otherwise it will throw in some syntax error. Say remote cell receive, and most of the thing you can see that's the same that I'm using, that is there in the upper lines. Then I can go and give print command, print, because I want to see this output. And here also if I want, I can give time dot sleep 1. Alright, so we have successfully edited one small portion of program here. Once we edit this particular program, what we can do, we need to save and come out from this. So for that I need to click, say, escape, and then quit and write, that is QW, enter. Let me check that why, write and quit, come out, and then you can go and check the execute this particular program. So it is printing the NXOS v1 line by line. Oh, you can see that here it has error, remote shell. See, so that's the beauty of program. It will go and check line by line all the items, and if you miss anything, it will simply go and tell you, okay, you missed this particular portion. So what it is telling, that this error, this place we have error because the configuration is, the spelling is incorrect. So I should give cell like this, and now I can type escape, write and quit, and then let's run that program one more time. So it is checking all those things. Up to here it's good, and now you can see the output that is running that command, that is show NXAPI. So you can see that from Ansible, from one server, I can send the command and I can see the output also. So I don't need to go here to the NX or the Nexus box and SSH and check that output. Even from here also I can check the output. Okay, so that was the edit inside the small program that we have done initially. Next, I am going to show you about the automated NXAPI. Now, what does it mean? So suppose if you log into a Nexus device, you can run the commands via CLI. But suppose if you want to do some off box type of thing, means you're not log into the device and you want to do the changes, for that these programming and all the API calls are very handy and useful. So if we use, or say if we enable the NXAPI, what are the things that we are getting, what benefits we have? So to improve the accessibility of Nexus configuration, Cisco has introduced NXAPI REST. So we have this REST methodology by providing HTTP/HTTPS API such that specific CLI are available outside the switch. You can say this off box. Outside the switch I can do that. Combined configuration action is relatively few HTTP/HTTPS methods operation. That means that I am going to use the HTTP/HTTPS methods to perform the task. Not only does NXAPI REST support command and switch configuration, it can also run Linux bash shell command. So you can see these features, that I have the feature of both, plus I can be off box. From outside I can manage and monitor those things. Now here is the important point we have, that NXAPI REST uses HTTP/HTTPS for transport. So these protocols like HTTP and HTTPS, NX REST API uses as a transport. Configuration commands are encoded into the HTTP/HTTPS body. We are going to see this in the program. Use the post as delivery method. So transport, we have HTTP/HTTPS. For delivery, we have the post. And in the backend, NXAPI REST uses the NGINX HTTP server. So you can see it's a very important 3 points, that what is the transport, who is the delivery method, and where is the server. You can instruct the NGINX server to return request data either in JSON or XML format. So these options we have, all these options we have, correct? Now let me show you quickly that what are the HTTP main methods we have. So in HTTP and their methods, you can see get means read the data, post means insert, put update data or insert if a new ID, delete means delete. These are the HTTP methods that you will see in our program. These methods we are going to use. Now we have an example that enable interface VLAN feature on the switch using NXAPI. So we can use the REST API client, like we have this Postman, so widely used REST API client, to execute the NXAPI calls or wrap them in Python script to automate the configuration task. So let me go and log to the Ansible server. From there I can show you the script and then we are going to execute that. So here I have the NXAPI, say our REST API program in terms of Python. Now you can see I'm importing the request used for HTTP request, used for HTTP session, used to pass JSON. So we have some import, then URL library disable warning, a list of hosts, the same thing we have used earlier. Obviously the comment we are using this pound symbol. For each host we wish to connect. Now first of all I want to authenticate with the host or the user. So for host, if you want to authenticate, get an authentication token from the device. How you are getting? URL HTTP. Remember we have transport like HTTP, HTTPS. The delivery method is post. Behind the scene we have NGINX as a server, and output we can get as a JSON or XML format. Correct? So let me show you this thing here. So we have discussed this, that the HTTP, HTTPS for transport, the delivery is the post method, the backend server is the NGINX HTTP server. And then finally the output we can return either in XML or JSON format. Alright, so URL HTTP, login data, AAA user, attribute, name and password. We know that username and the password. Response, you can see the delivery method is post, URL, data, content and all those things. Alright, let's just scroll down. Let's see this complete program. Uncomment to see the raw JSON, print as a JSON output. Okay. If response is status code equal to request code, okay, that means authentication successful. At that time we'll get authentication successful message as a print, but if the authentication is failed, it will generate this failed log, authentication failed, like that. Now the token that we have, if we want to print that token, that is the response token, I can use this print authentication token, because see, this is the program. What is happening in the program? You're restoring all the variables. So say token response.json, IM data, AAA login, attribute, token. It is storing inside the token, and this token I am printing here. So authentication token, and you will get this token like this. Then the new line. Next we have to enable the feature called interface VLAN. So URL, you can see URL HTTPS host API, manage object, system JSON, data, top system children, feature module entity, children. It's like some programming terms used inside the Nexus box. So feature module children, inside that feature module we have feature module called feature module interface VLAN attributes, administrators enable, like that. Then the cookie, we can use that. Again, we have the token response post those cookie. So you can see cookie is called here inside the cookie data, and the entire programming format. Now again, if JSON, if response status code equal to request status code, that means interface VLAN feature enabled, otherwise it is not enabled. So what you can do here, you can pause the recording and you can go and check line item by line item, because again, once you understand the normal format, what is the common structure, then you can add and delete several lines. There is no problem in that. So next, what I want to do here, let me escape from here, and I want to run this program. Let me execute this. So here you can see the token. As per our programming, you can see first of all they are doing the authentication. If authentication is successful, then authentication token, and this is the token as per the programming output. Interface VLAN feature enabled successfully on the device. Otherwise, the response code. So if I go back here and if you see this particular line, let me go down, 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 down. Yeah. So this is for authentication, this particular condition. If response status code is suppose not equal to the request code, that means it will throw an error. Likewise, after enabling the feature module interface VLAN attributes administrators enable, if suppose this statement, if a statement will not match, it will print error. If this is successful, that means this feature has been enabled. Correct. So now what I can do here, I can go to the Nexus box. Let me log in here by CLI. I can check show run, and I can do show feature and include enable, because remember last time what was enable? Last time we have enabled NXAPI. Now we have successfully enabled the interface VLAN from the NXAPI, and this is one type of API. You can say is this particular script is not like normal Python script, but all the terms we have already discussed, that what is the transport method, configuration are encoded into HTTP, HTTPS body, post is the delivery method, backend is this server, and the output is this. So I hope you understand this particular section. Let me close here. In this section, we are going to create the VLANs. We have actually three different type of VLANs, say VLAN 10, 20, and 30. So what I'm going to do here, I'm going to create say VLAN 10, name will be web, 20 will be app, and then I'm going to create 30 as a DB. So web, app, and DB, these three VLANs we are going to create. And important thing here that we can mark few of the VLANs. So for example, this I will do hard code, this I will do hard coding, this I will create via variable. So like that we are going to create. Then in the other example, what I will do, I will make this as a variable, as an external variable. So from external call, it will come inside the program and it will execute that VLAN. So let me go to the CLI and show you this thing. Alright, so I am here inside the CLI. First of all, what I'll do, I'll go to NXOS. I will check, do I have VLANs created? You can see already VLANs are there. Let me delete the old VLANs, say 10, 20 and 30. Let me delete the old one because we have to create the new VLANs. So now no VLAN is there. Then I'll go to my Ansible. Here I want to create the program variables and all those things. So we'll do with a VI editor. I will go here and I want to create the VLAN. So create VLANs dot YAML. Whenever you are starting the program, start with 3 dashes. That is the common way we are starting the program. Now I can give the name. So for example, this is the VLAN Creation playbook. All right. Then hosts all, and then I can add the comment. Comment is say execute the task on all the hosts defined in the inventory. So what we are going to do here, that this particular program, I'm going to give input inside the inventory. I'm going to show you the inventory file as well. In our inventory, I have one Nexus NXOS 1. So we'll verify that as well. Then we'll proceed, gather facts. So facts is no. Always after the colon, I am giving the space. Now for VLAN 10, I can give the variable. So let's create the variable for VLAN 10. This variable is for VLAN say 10. The ID says 10. Name I can give web, like that, no problem on that. Very straightforward. Then what I can do here, I can define the task. So let me go here and define the tasks. Now if we do any mistake here, you will find that it will generate an parser error or some error, some syntax error, and then it will tell you, okay, this particular line you have done the mistake. So I can give the name, say insert VLAN 10 exists, because I'm going to do this via the variable, and then the same format for everything. So NXOS VLAN, this is the NXOS VLAN, correct. Then I can give the VLAN ID, because this is a program, so I have to give the curly braces space VLAN 10.id. Then close this, give the quote. Then we have the name in terms of variable. So name also I can use this, and then this is the VLAN 10 variable name into the name dot name. Close this. Then I should give the transport. Say if suppose if you use normal Cisco iOS for the Ansible programming, at that time your transport will be CLI. But here, because we have already enabled the NXAPI transport or mode, so we can safely use this. So now you can see that we have completed our one task related to VLAN 10. Suppose if I execute this, it will create the VLAN 10 with the name web, because this is one of the complete program we have. Even in somewhere, if you want to give the comments, so for example here, if you want to give the comment, you can go and give the comment like the symbol, and then the comment say execute the VLAN configuration, something like via variable. like this, something like this you can give, no problem. Now let me go and save this, so I can press escape, right, and quit. Now I have my VLAN, VI create YAML. Before doing anything, I want to show you the inventory. So here you can see inventory for NXOS for all variables. It's a local, we have the username and password for this. Now I want to run this. So let me run this Ansible playbook. And this is create VLAN.yaml and the input is inventory. If everything is correct, it will run and it will run without any problem. So it is telling that, okay, is this place you have some issue? Let's go back and check why it is telling an issue, why it has some issue. So let me press insert so I can see why it has this issue. It is telling this place you have the issue. Oops, you can see this should be NXOS. VLAN ID is correct, name is correct, transport is correct. So even if you have some small mistakes, you can understand that it will throw an error. So variable creation is correct. Inside that we have the VLAN ID and name correct. It's very small, simple program. And we'll write and quit this. Let's play this one more time. You can see this is successful now. And if I go here and if I check, at the moment we have created only one VLAN, that is the VLAN 10 as a web. So that's very good, pretty good. What we can do now, that we can add some other VLANs as well. So next what I want here, I want to add, say I want to hardcode VLAN 20. So then the same format, name, and you will find the repetition now. Ensure VLAN 20 exists. And then I can give the comment like this will be hard coded. Alright. Same thing you have to do, NXOS underscore VLAN. This you have to give. You want to create the VLAN for NXOS. The hard coding thing, how we can do, like obviously we have to give the VLAN ID and other stuffs. So give some space here. Say VLAN underscore ID. This time we are going to give 20 because we want to create 20, and it don't have any reference. You can see here they have taken reference from this variable. Now I am hard coding it, so there is no reference. I can give the name as well. This time this name is app. Then I can give the transport, say transport, that is NXAPI, and we are very much it. That's it. So now I can go and edit this program file, and if I run the playbook, say okay, one change, you'll find some differences here because VLAN 10 is already there. So only one change is there, but 2 times the program executed, means 2 places. And now if I check show VLAN, you can see I have 10 and 20. So likewise, if I want, I can go and add one more VLAN. This time I'll show you that how you can edit simply. You can copy, paste, there is no problem on that. I can go a little bit up so the lining will be in the same line. And then I will do this thing. Let's make this 30. Make this 30 and this will be the DB. Escape, right, and execute this file. If you want to see the verbose output, you can use -v as a string. 3 OK, 1 change, so 1 new VLAN creation. If you want to see more verbose output, you can use -vv twice. Even if you want to see everything, you can use -3v. and you can check all the specifications and related outputs. So now we are very good. You can see that I have successfully created 3 different type of VLANs. One is variable inside the program, 2 we have hard coded. So now what I want to create variable for VLAN 30, external variable. So say okay, external variable for VLAN 30 dot YML file. I can give any lengthy name, there is no problem on that. This external variable I am going to call inside the program. So let's do this. Insert and task. What is the variable? Variable is a VLAN 30. Then ID is 30. Then name is DB, and you should give a space between ID and this. So you can see very straightforward, one variable, outside variable. Let me save this. Now how I can call this variable inside the main program, and then how I can edit this. So let me go back to the main program, that is our VI and the YAML program. So VI create YAML VLAN. Now here where we have the variable, there I can add this statement. So let me go and let me scroll up and go here. What I want to add. What you want to add? You want to add the variable files, because we are going to call one, and here I can give say external vars.yml. Correct? What's the name? This is not the name, correct? So what is the name that we are using? I need that name, so right quit. This is the name, correct? I'm going to reference, so we'll go back, and here we'll give that name, whatever name we have. This is the name. All right, so we are doing good at the moment. Give a small space here, and then here I can put the comment. Say this is the external variable, like that. You can give the comment here, and then we have given the comment. Now we have to create the variable type of program. So what I have to do here, I should delete these lines, because here I need to create a variable type of program. What I want to do here, that I want this type of thing to be placed here, so I can paste here. Okay, alright, copy paste will not work here, but simply what we can do, we can copy this particular section, and then we can press I as an insert. I can go next, I can press enter, and then I can paste that. Now here you can see that VLAN ID, I need to change that to 30. That's it, means a small edit we need to do. And here also I need to edit this 30. So now you can see that I have 10 as an internal variable, 20 as a hard-coded VLAN, and 30 from the external variable called from this place. Correct? So now we are very good, and let me save this final program. Let us run this program. Let's see if everything is correct. Variable files has some issue. So it has some issue here. It should not have any issue. because in the same line we have given the variable var underscore file. Alright, so as you can see here that this place I have some issue, and now they are in the same line. So those variables and all those things should follow the same structure, same line. Wow, so now you can see we are good, and our target is now successful. So if I do go here, if I do these things like no VLAN 10, no VLAN 20, no VLAN 30, I'll go to my Ansible here, and if I run that program, if I come here, if I check the VLANs, everything has been created. So we have web, app, and TP. That's good. Let's just stop here. In this task, we are going to create multiple VLAN interfaces. Over the VLAN interfaces, we have to assign the IP address, description, subnet mask, etc. And we are going to use the loop condition. So we have one with condition. With that, we are going to execute the task. Here you can see that we have the VLANs 10, 20, 30. Over that, I am going to assign or put the IP addresses. How I'm going to achieve this task is that first of all, I create some variables. So I'm going to create external variable with these parameters, and then these external variables I will call inside the main program. If you want to take the reference, then you can go to these links and you can check the Nexus OS interfaces, Nexus IP interfaces, and you'll get nice explanation about what we are going to do now. So let me log into the Ansible. So I'm inside Ansible. Let's create the variable file first. That will be the external variable for say VLAN.yaml. And here we'll start the variable thing with 3 dashes. I can give VLAN interfaces. Then I have to give a name. Name and the VLAN is say 10, comma, description. This is my web VLAN, comma. What is the IPv4 address we have? Say 10.1.1.1. And then we can give the mask. That will be 24. Same thing I'm going to do for VLAN 20 and VLAN 30. So what we can do, either we can do this over Notepad and we can paste, or here also we can go and edit. Label should be matched, so that's why this and this lines should be down in the same place because we are in the same label. Give this as a VLAN 20, description is say app, then IPv4 address is 20, here it is 30, this is DB, then we have VLAN 30, and then we can give the same label space. So now I have my external variable. I can write and quit. I'll copy this external variable to use in the main program. The main program is say interface VLAN IP dot YML. Start the program. I'll start with say name, and the name is VLAN interface configuration playbook. So this is my playbook. Now inside this, in the same label, I can give this host as all, and then we'll give gather fact. No. Finally, I have to give the var location. The var file name is this external var VLAN YAML. So we are very good with the creation of the variable or calling of the variable. Now we have to create the task. So I'll go here, I will create the task. So I'll give the name here in the same label. So name is admin up the VLAN interface. And here I can add the comment as well. So let me add the comment. Say the task will be for admin up and interface name, like that. All right, no problem. We'll continue. And then in the same label, NXOS interface. Below this, we'll go to the next label. So I'm going to define some interfaces and other parameter. So interface is in terms of variable, that is the item name. All right, and then what other thing in the same label? So in the same label, I can give the description. Description is item dot description. All right. In the same label again, I have to define the admin state. Admin state is up. Anyways, if we found any problem, is if the execution having any problem, then it will throw an error. Once it will throw an error, then we'll go and correct it. So far, so good. You can see that I have created one task. This particular task will call the interfaces and then it will give the description, but how it will execute to the different interfaces. So for that, I have to give the condition. So my condition is with condition, with items. What are the items I have in the same label? I will define the items. VLAN interfaces, and we are done. So we are done with one of the tasks. Now the second thing what I want to do here is create one more task to assign the IP addresses. I should have the same label and then I can give IPv4 addresses configuration for the VLAN interfaces. Correct? Should check the label. So here in this particular label, NXOS underscore IP underscore interface, I can go down and under the interfaces, I can give I can call the function like we have called in the above task, that is the item dot name, and then I have to give the IP address as well. So first of all, give the version is v4, give the address is again inside the variable item. So item dot IPv4, close this braces, and then finally we have to give the mask. So mask will be 24. That will be item dot mask, and let's close this. So why this mask is showing this? Because we have double quotes here. Remove one. Now it is okay. Finally, from where it is going to execute all these things. So then I have to give with items under the same label. And what with items we have? It should have the VLAN underscore interfaces, close the quotes. So now we are done with the program. The only thing I want to match here that this with statement that I have should have the same label. So if I go on the top, yeah, this name and NXOS, they are in the same label. Interfaces should be in the same label. Rest of the things are okay. Now, if you see here, you don't find any problem, it's okay. So first task will run and it will tell, okay, what's the name, what's the description, administrate up. The second task, what it will do, that the name of the interface is IPv4 address mask, IPv4 it should be like that, and it will execute. So let us go and execute this particular program. Before execution, if I go and check show IP interface brief, I can see the IP addresses are already there, so they should not be there. Maybe some old program is running. So what I'll do, I'll go to interface VLAN 10, no IP address, interface VLAN 20, no IP address, interface VLAN 30, no IP address. We'll see. Now you can see nothing is there. So let's go here and save this program and run the playbook. So Ansible playbook is interface VLAN, the input is inventory, run this. Now you can see this name and issue here because they are not in the same label. So it should be inside the same label, otherwise these things will come. So where it is, IPv4 address configuration for the VLAN interface, here it has the problem. You can see here this particular place, it should go back. So let me go back here. Now it is okay. Let's try and run one more time. Then we can see NXOS IP interface. Here the label is not correct. So let's see NXOS IP address, and yes, that's also correct. That's also true because this will also go one space back. So you can see the label should match, otherwise it will keep throwing an error. VLAN interface configuration playbook. So let me correct all these labels and we'll run this program. Alright, so once we have done the correction, let's save this and run this program one more time. Now you can see that it is running fine, and you can see the output here, the interfaces and the description IPv4. So here you can see this execution. This is okay. Now if I go here to the NXOS and if I check show IP interface brief, you can see that all the IP addresses and the interfaces are up and running. If I check the VLAN 10, you can see here the VLAN 10 name web. If I go and check interface VLAN 20, oops, I can go and check show run interface VLAN 20 and description no shutdown. For VLAN 10, I think the description is something like that. We need to check the program itself and the variable itself. So if I go and check VI and the external variable, so VLAN 10 description web VLAN and all these things seems correct only. 202030 is showing correct. Maybe some old program is there. So let me do one thing, interface VLAN 10, no description. And let me go and run the program, or let's see. So that's the beauty of the program, that we can run all the time. There's no problem on that. So it is telling, okay, description. See, the description is web. And now here, if I go and check show run interface VLAN 10, now it is okay. All right. So we are good. We have successfully executed the program. Let's stop here. Now I am going to show you that with help of conditions, how you can put the condition. That means that how you can better utilize the with condition with certain loops as well. So for example, say you want to give some comments for Ethernet 1 to 5 associated with web, the VLAN 10 associated with Ethernet 1 to 10. So you can see I have range of interfaces where I want to put the comments. This can be easily done with help of condition. And here in the diagram you can see all these interfaces I'm going to put the command. So I'm going to call some sort of loop or some sort of condition where it can be easily done. So irrespective of 1 to 5 interface or 1 to 200 interfaces, doesn't matter, because anyways we are going to use the programming feature. The for example, some condition, if that condition will met, then only it will come out of loop. Otherwise that loop will go on, and it will execute those certain commands over that period of time, over that period of condition, until that condition matches, until that loop will go on. This is the reference link. Here you can see, you can go to this particular link and learn more about these conditions. Let me show you this thing in the lab. We are inside Ansible. For this, first of all, what I will do, I will create the external variable. So I have external variable, and obviously that is the YAML. So in this particular external variable, what I want to do, I want to assign the physical interfaces. So let me give that physical interfaces. These physical interfaces, what physical interfaces I have? So let me give the value. Say Ethernet 1/1, and that will be, say, VLAN 10. Likewise, I have the interfaces. So what I can do here, I can simply copy and paste all these values. So let me paste these values, and from E11 until E15 I have. So here I need to edit this. 5, 4, 3, 2 and 1. So I have 2 and 1. Like that, I'll create a variable for VLAN 20 and VLAN 30. So let me create that also. This I will go and edit. Say for example, this is 6. This VLAN is 20. So 6 to 10 we have other variable. So let me copy and edit that also. So now I have 6 to 10. Let me go up, and here I'll make this 7, 8, 9 and 10. Now next what I will do, I have variable from interface 11 to 15. That will be VLAN 30. So we'll edit that also. This is my 30. I'll copy this, and now you can see that the only one line we have, but we can copy and paste. That is also one feature we have in the program, that all the time you don't need all the new statements and all the new variables. Once you know that okay, you have this block that I have defined for these tasks, same thing you can reuse. Even the program commands also we can reuse. So now I have all these things. Let me save this. So this is my external variable from 1 to 5, 6 to 10, and then 11 to 15. Yeah. So now we have external variable. Now I will go and create my main program. What I want to put the comments to interface, and then we need to create the main program where I will do all those comments and everything. So let's start the playbook. The name of the playbook, this playbook for setting the interface description. Obviously I should give one space here. Now we'll start the program from the same level. This is applicable for all the hosts. Gather the facts, we'll do no here. Same level, you can see I'm working on the same level. So the files, the variable files, what is the name of the variable? I should check this, or I should copy and paste. This variable file name is external var. So I will go back and I will give the name under this external var. Obviously I should give this also as the label. Alright, so we have defined the variable as well. Now I will create one block. Say for example interface 1/1 to 1/5, and then same thing I'll copy and paste for other interfaces with some modification. So let's do this. I should go to the task under the same level. You can see the name and the task. So let's do that, task, and then I should give colon here, otherwise it will throw error. Then let's start the task. So what's the name of the task? Name of the task is set the physical ports description for web. So we have web app and DB. Likewise we are going to do under the name NXOS underscore interface, and for that we can refer the link that we have checked in the PPT I have shown you. So now let's go under this label again. We are following the label. So here I can give interface. You can see interface, and then what's the name under this? So item dot name. Close this. All right. Under same label that we have the interface, I can give the description. So give that description as well. And is this description related to web VLAN? All right. Now I can give the transport. So once we'll do all these things, then for other interfaces also, I am going to use the same structure. Now what I want here, this is with the items, what items it has. It should have the physical interface. So physical interfaces, and then I can close the braces. We're almost done. The only thing I have to give here is the condition. So up to which program this loop will run? This loop, this conditional statement will run till, so I'll define here, till the item value or item VLAN matches 10. That's it. So here you can see, only thing that we need to identify here, that our label should be matching, otherwise it will throw an error. Okay. So here you can see, if I want, I can put some comments as well, say with items till how long it will run. Here you can see the condition. So I have physical interfaces that will come inside the variable, and it will run up to, it will match, okay, up to E11 VLAN 10, E12 VLAN 10, like that. So it will match up to that point. So likewise, what I can do now, that I can go ahead and I can create the same thing for 20 and 30. So let's do that. The only thing I need to change here, for 30, this will be DB, and small edit I need to do here. So this will be DB. Here it is 20, and here it is app. Likewise, here this will be app. So once I'll do up to this point, you can understand that I should follow the label. So you can see that name, we have here the name value. It should be under the name. So this label, you can see this is not matching. I can go back. Now this is okay. Then interfaces, then description, all those stuffs are okay. Say width, you can see width, that's okay. When condition, simply I need to adjust this name, and that's the thing here. Whenever you are doing this programming, your label should be matched, otherwise it will throw an error. So now we are very much good with this particular portion. Let's run the playbook. So I can run this playbook, comments and the input inventory. Where files is not a valid attribute for a play. So we'll see it. And if I go up, small modification needed here. This is actually where. Okay, so let me insert. This is actually where's underscore files. So now this is correct. So you can see if any small spelling mistake also, it will start throwing an error. Let's see. Now it is running the playbook, you can see, and it is setting the comments or description over the interfaces E11, 12, 13, 14, then 16 to 110, 11 to 15. Set the physical port description. So you can see the web thing is happen, then the this yellow color, the app is happening, and then finally you can see the DB is happening. Although they have started the scanning from the first variable, but whatever variable we are, or whatever task that we are calling, it is going there and doing or setting that things. So if I go to show run and then interface E1/125, you can see all those comments. Then 6 to 10, all app, then 11 to 15 dB. So this completes our task. Let's stop here. In this section, I'm going to run one lab where you can see that how we can store the output over JSON format inside the local destination. For this, you can go and refer the link below. Say local underscore action. This is the shorthand syntax for execute a task on a local machine where the Ansible playbook instead of the target device. So let me show you this in the lab so you can understand more about this. For reference, you can go and check this link. Once we collect that output in JSON format, then how we can see that output? So what we are going to do, that we are going to create one playbook where in that playbook I'm going to store VLAN 10 interface details. Okay, so let me log into Ansible and show you this particular lab task. We are here in the Ansible. I can go and create the program. Program maybe say local output in JSON format. All right, so let's create this program. Let's create this playbook, and the name I can give name as a, so let me give the name of this playbook. Say playbook for getting the VLAN 10 interface details in JSON format. Alright, let's start. So the same thing that we used to do, host is all, then gather facts. Yeah, gather facts is no, and then we can start the task. So let's start the task. What I want here, let me start the label under task. Get the interface details. If I want, I can put one comment that VLAN 10 interface details. So interface details store in JSON format. All right. Then inside this name, obviously we have to give NXOS command. So this time I'm going to use a command. What command I'm using? The command that I am using is say commands, simple CLI command like show IP interface VLAN 10 like that. This is the command that I'm going to use. All right. Then you can see here that if I give a space, because this is a programming thing, so here also I should give a space. Otherwise, if I'm not giving any space, then I should not give space to the other place as well. Same label, what I want to do, transport is NXAPI. Now I'm going to use a register, and that's the thing that you can go and refer the URL. So what is the register here? Register is interface facts. Now I want to give this to the local destination, this particular output. So this output collect to, say collect to local destination at the rate of JSON format. So local destination at the rate of JSON format. Like that I can give the comment. And here also if I'm maintaining the label, so here also I can maintain the label, no problem. Now we'll move next and give the destination. So I am here now. And let's start with the label. Just label will be the same. Otherwise it will throw an error. So let's do this. All right. Local action. Copy the content. So what is the content we have? Content equal to interface facts that we have here. All right. And what's the destination? So the destination equal to ./interface, and then I can give the name. What is the inventory? Host name. And that's it. We are almost done. The format that we are using is JSON. We're done. So let's save this program and try to run in the playbook. This is the local output and inventory. So now we can see that this program execution is successful. Playbook for getting the VLAN interface detail, get the interface detail, copy, task copy. So we have two tasks, you can see task 1 and task 2. And now if I want to see the output, I can go and check the interface. You can see this is the output in our program. So let me show you the output format as well. The output format is destination is interface, then host name is NXOS v1. It's like that, correct? So we'll go back here, and if you want to see the output, I can see like this. Now this output, you can see that this is in the JSON format for that particular VLAN 10 interface. You can see the IP address and all those stuff for VLAN 10. But again, this particular format is not that much helpful while we are reading this, because this is not in certain structure. Obviously, if I copy this and if I try to import in or try to convert this output in other formats, it's okay. But this is still not in that way that we can read it. So that's why we are going to convert this JSON format to other format as well. So let's just stop here. This JSON and the export that we have done for this particular task. So the agenda was to show you that how you can give the local destination. In the next upcoming labs, we'll see that how we can convert the formats in the other format. As we can see that in the JSON format, it's very difficult to read all these outputs. So that's why we have other option that we can convert that into the Jinja2 format. You can see here that okay, the interface prefix subnet mask, like that we have fmt_interface. If you want more information about Jinja2, please go and visit these locations, these URL. You'll get more understanding about this Jinja2 format. Anyways, we are going to perform the lab task and where you can understand the format. So let me open my Ansible. We are here in the Ansible. Here you can see the Jinja2 format, J2 format, and let me come out. If I come out here, you can see this is the J2 format, Jinja2, that I want to take as an input for my playbook. So what was my local output, that last program that we have created? Because this program I want to edit, and this input I will send this input to the J2, and J2 from there will get the output. Like that we are going to do. So let me go out here and let me create new program. Say that will be new format, say j2.yml, and here first of all I will insert that old program, because here I want to do small modifications. So first of all, what I will do here, I will add the variable. Let me add the variable, and that is, say, interface VLAN 10. Then inside the task, I will go here to the commands, and inside the command, because this is referring one variable, so I will put the braces here and I will give the interface. Let me close this. Up to here, no change. If I want, I can delete these comments. These are not needed at the moment. I can delete these lines, and I can delete this also. Let's create from 0. Now let's go and create set facts. Should be in the same line that we have. Set fact, and then fmt, that is the Jinja2 format, equal to the braces interface fact, and that will be out. And let me give the 0 here, that table. So we are defining basically table and row. Table is interface, and for more information obviously you can go and refer the document. Interface, let me close this. Once we have this, then what I want this template, that is the source. What is the source I have? Source equal to interface template J2 format, obviously. That is going to be source. That just now we have seen this program, and the destination equal to interface, and that will be inventory underscore host name, and then we can close this and then txt. So this will be the final program that we have. Let me run this program. So I'll go and run this program. Ansible playbook, new format J2, and then the inventory. Oops. We should give .yml. So yml, and run this. Now small errors are there. So limit Ansible new format to retype. The task includes an option undefined. Some small mistakes will be there. Let's correct that mistake. So let me go back to the program, and let's see all these lines one by one. Here I can see the spelling mistake, so let me correct that. Inventory as underscore hostname. Rest all these things seems to be good. Run this program. Template could be wrong, but looks like it might be issue with the missing quotes. So if I go here and let me give spaces here, generally whenever we are using the quotes we are giving this space, and rest of all the places the quotes are correct. Let's execute one more time this program. So program seems to be 100% correct. What you can do here, just to refer the document that I have shown you in the PPT. Once you refer the document, then you'll find that okay, how to write all these codes. Now you can see that it is running properly, there is no problem, and now I can go and check the output. So for the output, where I'm sending the output, if you go and check the output file, the output file is in intf inventory hostname.txt. So let's go there and check the intf NXOS.txt, and here you can see that all those inputs it took, and it is showing here in this particular format. Remember what is our original input file? Input file was this, and then from this input file we have the output txt file. Okay, alright, we are done with this. Let's stop here. Now we are going to learn that how we can group different type of variables. Suppose if we can group different type of variables, then we can call inside the main program. So for example, I'll create inventory where I'll add say Nexus 1 and 2. Then I will group Nexus 1 inside dev test, Nexus 2 inside production, and according to that, I'm going to run the program. So let me first create the variables, say like host variable, where I will give host name as a Nexus 1 and Nexus 2. Then I will create group variable. In that group variable also, I have programs like feature 1 and feature 2. There I'll add certain features for dev test and for production. And then in the main program, I'm going to call those functions. Okay, so first of all we'll create the inventory, and next we are going to create the variables inside the folder. So let me show you that how we can do that. Let me log to the Ansible. So here I am inside the Ansible. What I will do first, that I will make directory, say for example host variable, and we can go to host variable where I want to create one .yaml function or program, say NXOS v1.yml, and here I will put host name as NXOS version 1 or NXOS switch number 1, so that is number 1 and number 2. That's it. Then I can come out from this place. Next time I will create NXOS 2 like this, and here I will give number as 2. So now you can see if I go back to my list, inside the host variable, you can see that I have two programs, NXOS 1 and 2. Okay, so we have two devices listed inside the host variable. Then again I will go and create say group variable. Now why we are doing this, we'll see. So here I'll create one other program, say devtest.yml, and I'm going to give feature, say features. This will be interface VLAN. I can go out from here. Then I'll create, say, production.yml. Here also I will go and give features, but here I am going to use more feature. So for example, let me give a space as well. Interface VLAN, and the other feature is, say, private VLAN. Alright. So once we are done up to that, let me write this also. If you see ls-la, you can see that devtest production inside the group, Nexus 1 and 2 inside the host variable. Now I'll go up from here, and we have one file called inventory. This inventory file I will edit. So what we will do here, we are going to add Nexus 1 is already there, and then we'll add Nexus 2 as well in this. Once we have Nexus 1 and 2, then we are going to group. So how we are going to group? We'll go inside devtest, and inside devtest I have, say, Nexus OS v1. Then I'll create one other group called production. Inside that NXOS v2. Later in the main program, we are going to call the inventory, the host variable, the group variable, everything. Okay, so this is it. This is the final program that we have. So now I can go back and write it. I can check the inventory program, and now we can see, okay, this is my inventory. So let us stop here. In the next section, we are going to write our main program where we are going to call all these functions. Now we have groups and variable defined. Let us write our main program. So I will go here and I will start vi main.yaml, and then we can start our playbook. So what I want here, the name, say configure. We can do like this, configure playbook using groups, because we have certain groups, and the host all, the same thing that we have started our program earlier. No much difference on that. Gather facts, no. Then I can start the program from the task 1 and task 2. So task I have, first of all, that is the name, configure host name, because we have two variables, remember, the variable number 1 and variable number 2 inside the folder itself. So I can give the comment that this particular variable is imported from the host underscore vars directory, correct? And remember, when they read the program, they will start from top to bottom. So first of all, they are going to read from this particular directory, that is host underscore var. Next time it will start reading from groups underscore var or group underscore var, like that. So this is NXOS system, and then the host name I can give in the quotes, host name, and let me close this. After that, we should give the transport. So let me go back here and give the transport is NXAPI. Likewise, I should go and configure the other portion, the other group variable that we have. This time I want to enable the features, and the comment I can give, say this variable is imported from the group underscore wars directory. Alright, so now I can go here and I can give an NXOS feature because we want to enable the feature now. Then I can go and give the feature, and feature is nothing but item. Finally, I'll give the state of this feature as a enable, because we have different features inside different group, like production has different and dev test has a different feature. Finally, the transport is NXAPI, and we should give the condition. So I'm going to give the condition like with items, and then we can give the quotes. So let's give that features. I should give correct spelling, or while writing it, it will throw an error. So we are almost done. Let's save this particular program. Before saving this program, you can see it's very straightforward. I have two tasks. First of all, it will read the task from host underscore var directory, and then it will go to group underscore var directory. In the first instance, it will write the host name, because in the variable we have created the host names inside this directory. Second, it will go and enable the features for those devices. Correct? So let us write this program, and then we will execute this program. Alright, so let's run our Ansible playbook, and the program is main.yaml from the inventory, transport with items. So we can go and modify some of the syntax error we have. So we have syntax error at this place, and it is obvious. It should be in this particular line, and then we'll run this program. Now it is running the program. You can see configure host name NXOS, yes. So host name program, the first task is 100% correct. The task number second has some issue. So we need to check the item and the variable name. So we'll go to the main.yaml and we can edit that, we can verify that. So what I observe here, that this program is correct. So I should go to the folder where I have groups variable, and from here I can check the configuration. So here I have two program, production and dev test. Let's see that. Interface VLAN, private VLAN, interface VLAN. So what error I have? Interface VLAN change false item. Value of the state must be enable, disable, got enable. So you can see that value is not defined inside the state. I just fixed the label, and after fixing the label, you can see that it is working fine. So same program, nothing is there. Simply I have fixed the label, and then if I go and if I run my playbook, now you can see they're configuring the host name. Once they configure the host name, after that they will enable the feature. So Nexus 2, we have these features. If I go to Nexus 2, if I see show feature and include enable, I can see private VLAN, NXAPI, etc. So if I remove the feature, say no feature private VLANs, no feature, for example, NXAPI, like that. If I go here to Nexus number 1, and there also if I do no feature NXAPI, even we can change the host name as well, but leave this as it is. So now if I run the program, because they do not have transport, so this is not working. So we should give the transport first, and once we have the transport, then it will work. So then we can add the other features and other inputs related to that. So now you can see now it is working perfectly, no problem. So this is the way that we can use the groups for the complex program, and we can import those groups line item by line item as per defined in the main function or in the main program. Let us understand ACI fundamentals. ACI is application-centric infrastructure. It is something like you have the leaf and spine structure, and all these leaf and spine backbone, they are managed via some controller called EPIC controller, application-centric controllers. Now the question arises here that why in the first place we need this type of a structure. Now you can think in the perspective of the developers. For developers, what they want, for application developers, they want that, okay, a client has some requirement for new application, they want to write new code, they want to deliver it as soon as possible. What are the constraints these developers have? These developers, by the end of the day, they are depending upon the network infrastructure. And in the traditional network infrastructure, what are the things we have? We have VLANs, subnet, protocols, ports, routing constraints, security constraints, means we have barrier everywhere. It's not that the traditional network is there for application. Means network is there, you can write your application, the application will flow over the network, but it is not application based network. It's a network, on the top of that you are writing the applications. Correct? Now considering these barriers into mind, this particular ACI infrastructure, that is application in the center infrastructure, has been developed. And if you see that ACI infrastructure, you will find that yes, exactly, we have different type of tiers like web, app and DB. That is the 3-tier application infrastructure. And then we have relationship like provider and consumer and the contracts in between them. In general, in short, that now the network is there to support applications. Means the application is in the core and then we are designing the network. That's the overall idea we have with the ACI. So what is ACI? In the old, IP endpoint based network, but in the new we have application based network. So initially we have IP based network, still we have IP based network, but all those constraints related to VLAN, subnet, port, protocol, security, those have been removed, and now you can think network as an application, and you can even you can change your network, like you have some programming structure or you have some template based structure from where you can change your network structure. Sometimes maybe you heard about some terms like now we have underlay and overlay type of network, and that's true. That's actually true, that you may have any type of physical connectivity in the bottom. So here in the down, you may have any type of connectivity, but the view of the network will be changed. So your underlay and your overlay. So this underlay has been abstracted, and when you are talking about the overlay view may be changed. So on the top or from the top, you can control your underlay or your physical infrastructure. So here you can see that, okay, I have option that I am doing application based networking. We have new software based network. We have software defined networking management. Now we are not declarative, but we are giving the promise to the customers. So now the new model is that, oh, you want to create 1,000 VLAN, I'll create. You want to create 100 tenants, I will create. You want to create 1,000 subnets, I will create. Those things, like we can guarantee, we can promise to the customer that yes, we'll do, and we'll do it very, very fastly. Why? Because not only they are supporting various object model, but we can do the programming as well. Now finally you can see that's the pure SDN thing, that separation of control and the data plane, and that's true, that your data plane is somewhere, your control plane is somewhere, even you have your management plane as well, and from your management plane you are writing the code to the control plane, and by the end of the control plane pushes all these things to the data plane. It's like that. Now here you can see that ACI Fabric is an IP-based fabric that implements an integrated overlay that we have discussed, that we have underlay overlay, allowing any subnet to be placed anywhere. That's the true power, that now we are not fixed with the network. We have the mobility inside the network. That means that any subnet to be placed anywhere in the fabric and supports a fabric wide mobility. So now you can see that we have new capability for the subnets, that my subnets can move. So we have the mobility feature. For virtualized workloads, STP is not required within the ACI leaf and fabric. The spine and the epic doesn't run STP instances. So now we are in the complete ACI fabric, that is the leaf and spine type of structure. And here in the diagram you can see that you have the cloth fabric where you have leaf, spine, leaf, spine, leaf, spine type of structure, and all these fabric we are managing or we are monitoring from the epic controller. Now in the core you can see that these devices, they are running Nexus 9K, so either 9300 as a leaf, 9500 as a spine. This leaf and spine or this Nexus can run either in a standalone mode or in ACI mode. So we have dual benefit. Not only we have the dual benefit, but here in the points you can see that this particular switch, actually this is best in the class efficiency. So its overall throughput, its performance, its uh, support to the programming, means you can program the ASICs, all those things has been very enhanced, very modernized, and that's why they are best in the class. So the Nexus 9K platform has two modes: standalone ACI. Nexus 9K utilize an enhanced version of NXOS operating system. That's the key. We have the enhanced version of the operating system to provide a traditional switching model with advanced automation and programming. So you can see now, because I have very good hardware, so I can do the programming. Because I have modern ASIC inside this, so I can do the automation programming. I can enable new capabilities. That's the key we have. In the second mode, that is the ACI mode in Nexus 9K, provides an application-centric representation of network as a whole. So here we have the application-centric infrastructure. If I run in the ACI mode, utilizing advanced feature and profile-based deployment, abstract the complexity of the underlay network and improving application visibility and greater business agility through the DevOps methodology. So you can see that how many key features we have inside the Nexus 9K box. Either it's a 9500 or it's a 9300, because of the advanced or enhanced ASIC that we have inside these boxes. They have much capability to run as a application centric infrastructure, to do the programming. It has more visibility and it has much better throughput as well. Now later we'll discuss about the application infrastructure inside the ACI. So for the moment, let's stop here and we can continue in the next section with some more theories of the ACI. Let us continue our discussion with ACI. Now we are in the world where we have the three-tier application architecture, rather than we have the architecture related to secure distribution and access layer. So here you can see that in this three-tier architecture, I have web, app, and DB. Now inside this web and app, I can have some policies. Inside app and DB, I can have some policy. From the external world to the web, I can have some policy. Now the nice thing about the ACI infrastructure, that you have non-blocking free, penalty-free overlay. So whatever encapsulation that is coming, or whatever traffic, either it's a VLAN tagging or it's a Ethernet frame, or it's a the traffic is coming from the virtual world, or the traffic is coming from NVGRE encapsulations. All those things at the moment they reach up to this particular leaf switch, ingress and the egress interfaces from one VTIP, that is the VXLAN tunnel endpoint. From one VXLAN to other VXLAN tunnel endpoint, they can be non-blocked. They can move freely. And that's the interesting part we have inside the ACI Fabric. The other very interesting feature we have, that now the devices, they are not restrict, or they are not tightly coupled with the IP addresses. So initially in the traditional network, what you have, that for security you have subnet network, you have subnet routing, you have subnets, and all your endpoint devices, they are tightly coupled with these IP subnets, VLANs, etc. Now we don't have that restriction. Now as per the location, so we have the location and the identity. My devices can move from one location to other location without any problem. And that's the power we have in the ACI Fabric, that we have the mobility feature. The location and the identity can be changed. So the IP, subnets, and those attributes, they will also move. So we don't have restriction with the move or the mobility of the devices. So here you can see in the points that ACI Fabric decouples the endpoint entity and associated policy from the underlying fabric forwarding graph. That's the main key we have. Then it provides a distributed layer 3 gateway and ensure optimal layer 3 and layer 2 forwarding. The fabric supports a standard bridging and routing semantics without a standard location constraint. Any IP anywhere, that's the key. So we can highlight this thing that we have any IP anywhere concept and removes flooding requirements for the IP control plane, addresses resolution, say ARP and the GARP packets. All traffic within the fabric is encapsulated within VXLAN. So if you mark very important points, what you can do that the all traffic will be encapsulated inside VXLAN. Any IP address anywhere. It ensures optimal layer 3 and layer 2 forwarding. We have non-blocking penalty-free path. So if you compare with STP, you'll find that we have penalty of 50%. Here we don't have. Some other important points that I can create logical entity or tenant up to 64K. A single fabric can support more than 1 million IPv4, IPv6 endpoints, 64K tenants, and more than 200K 10G ports. So you can see that we have features called mobility. We have feature like high speed. So it has very good high speed. And then we can create some logical constructs as well. Apart from that, you can see that the ACI Fabric enables any service, either it's a physical or virtual, anywhere with no need of additional software and hardware gateways to contact between the physical and the virtual servers, and normalizes the encapsulation for VXLAN, VLAN, network virtualization using GRE encapsulation protocol, that is NVGRE. So you have any to any movement irrespective of from where you are taking the traffic as an input. And here you can see in the diagram. So I may have Ethernet frame, I may have encapsulated frame, VXLAN encapsulated frame, NVGRE. The forwarding is not limited to nor constrained by the encapsulation type of the encapsulation specific overlay. So you can see we have very nice features. One other important feature I want to highlight here, that once you bring up the fabric, so you have the class fabric, that is your spine and the leaf architecture, your spine and the leaf architecture. You have connected your controller with the leaf. Now this bring up process of the fabric is actually very easy. You connect all the devices, they will use LLDP. They will search all the leaf spine, and then it's very easy. You will get some boxes. Okay, you want to set the infra VLAN, you want to set the IP management, you want to set this username, password, you want to set the say out of band management, password, gate, etc. You will get some options A, B, C, D like that. Once you fill all those options, then you can build your fabric. Then you can go to the Epic dashboard and you can give the names with the respective serial numbers, and your fabric will come up and running. The last important feature that we can discuss now here is the application statelessness. Now the application statelessness, you can see that okay, now we are in the 3 tier of the application like web, app and EPG. In between that, I can provide some policies. Now, while doing this, there is a stateless filtering between the endpoint groups. So what is the endpoint groups? Endpoint groups are nothing but the VMs who has the common task. So I may have endpoints, or you can think like same type of endpoints. I can group them inside a function, or I can group them, so that will become endpoint group. So common type of web endpoints I can group inside endpoint group. Common type of application I can put inside endpoint group application, like that. So grouping of common services is endpoint group, and we can have individual endpoints. Now there is a stateless filter between endpoint groups that may be able to eliminate the need for some firewall within the data center. Contracts define, now again this new term contact, we'll see what is this. Contact define what an EPG exposes to other app tier and how. In other words, any communication is not explicitly allowed. So now if we have two different endpoint, two different services group, in between them you need some sort of agreement. That agreement is nothing but the contract, and inside contract you need some sort of ACL. The technical term or the ACI term is the filter. So you need filter, you need subject filter inside the, if you want to communicate in between two endpoint groups. By default, they will not communicate. So this will eliminate some sort of firewall rules that we want inside the DC for the security provisioning, etc. So now you can see that, okay, you have the endpoint that is single or device group. Endpoints may be virtual, may be physical, single or multiple subnets, health monitoring, the network security, QoS, TCP, UDP, redirection spans, L4, L7 services like firewalls, load balancer, orchestration, and management network analysis. Wow, so you can see that how many features we have. So not only the features we have, so we are thinking we have so many features inside ACI, but think like this, that these features and the ease of use. So feature with respect to how I can use it, how easily I can use it, that's the key we have in the ACI Fabric. Now ACI allows application developers to expedite deployment while ensuring a consistent policy framework. ACI decouples legacy constructs such as security, addressing, routing from the underlay infrastructure that we have already discussed. ACI allows both physical and virtual endpoint to govern same policy. See how powerful is this? It's really powerful and nice tool we have in the data center at the moment, that we can automate the data center and add so many features, and still by the end of the day we have high speed and high deployment speed as well. All right, so now we have construct of ACI, means what are the building blocks for ACI. On the top view, if you see that in ACI actually have two types of component. So what are the components we have in ACI? One should be logical, other one should be physical. Now we know all these SDN solution, whatever we have in the market, that you have the control plane, you have the data plane. So let me draw here so you can understand more on this. That means you have data plane who is doing the actual data forwarding, and that you can think that, okay, that is your underlay devices, and then you can abstract those things to the overlay. So that means if you have some physical connectivity, those physical connectivity, it can be seen in other view, or maybe I have different views of that physical connection over the overlay to these underlay. So that's the reason you'll find that, okay, in all the SDN solution, for example, ACI also, you have two types of things. One is the logical, means one part will be the logical, one is the physical. Now if you see the overall fabric structure, you'll find that, okay, I have the management plane called the EPIC controller, from where I can manage the spine and the leaf infrastructure. So I have a spine, leaf, means cross fabric I can manage entire fabric, correct? Now, when you are thinking, or when you're seeing this spine and leaf structure, and then you have some edge devices, maybe Nexus 7K or maybe some other devices. So all these connections obviously related to fabric, they are physical connection. You can create template and you can reuse those templates over same type of interfaces. Either it's connected here, here, or maybe you have n number of leaf nodes, so spine and the leaf n number of leaf nodes you have, you can use those configuration. The other portion that I have is the logical configuration, and that I want to highlight here in the, you can see in the diagram that okay, I have the logical construct, that is tenant, that may represent customer, business unit or group of some logical entities. Now these tenants are part of virtual routing forwarding. You can see here VRF and the context. Then they are part of bridge domain. This bridge domain you can think as a VLAN for example. These VLANs have some subnets. Now again you can see that these particular VLANs, they are tied with endpoint group. Now, what is endpoint group? Where I have the endpoint. What is endpoint? Where I have the virtual or the physical systems. So overall the structure, you can see that okay, you can create the template, you can push the configuration, you have some logical entity, you have some physical entity. In between logical and the physical entity, you have some sort of a glue, something that will join the physical and the logical uh, construct, or the physical and the logical configurations. And yes, we have glue name as AAEP, attachable access entity point, something like that. You can refer the ACI documents. So what we have studied at the moment, that yes, I have the logical entity tenants, these are the logical containers. We have some default tenant to manage the fabric, to manage the fabric, to manage the IPs, to manage the management, like that. So we have management tenant, we have infra that will manage the ACI fabric, we have tenant for common task, we have tenant for the management purposes as well. So by default, once you open the Epic controller, you'll find three default tenants, and that should be there because of their use case. Here in the diagram, you can see that okay, something is coming from outside. So inside the logical entity, I have application profile. Inside that, I can define endpoint groups. Remember, endpoint groups are nothing but common task. So common endpoint related task, for example, web app DB, that can be grouped inside endpoint group. Bridge domains, from where you are getting the gateways or the subnets or the IPs. So the gateways are defined here in the bridge domain. They may be part of VRF. Yeah, that's indirect relation. So they're part of VRF. And then if you have different endpoints, say a web endpoint group and say application endpoint group, they will communicate with respect to proposals, contracts. So inside contract, I have subject and filter. In our Ansible program, we are going to create the tenant with the program. We'll create the application profile. We'll create the bridge domain. We can create the contracts as well. So for that regard, you should understand that what is the common terminologies we have inside the tenant. Again, you have the VRF mapped to the bridge domain, and VRF is like VRF, virtual routing forwarding instance, correct? In Cisco, we are using this VRF from long duration. We have bridge domain is the bound to private network, that is the VRF, represents L2 boundary which can be a span across switches, can operate in proxy, that is the default mode or traditional flood mode, limits the scope of broadcast, and the flood contains any layer 3 subnets as well. So bridge domain is also very important because whatever endpoints group you have, you are mapping towards the bridge domain to get the gateways. And then we have application profile, the logical entity. Inside the application profile, we use to define the endpoint group, correct? So logical container for endpoint group provides a label of health monitoring. QoS can be applied on the application profile. Finally, we have one example where you can see that okay, I can group the common tasks. So endpoint group related to VMs, related to web application, endpoint group in application related to application VMs, or maybe physical devices also, EPG in database related to EPG services. These services, because they are the different EPGs, endpoint groups, so they need contract to communicate with each other, because again by the end of day they are the stateless features. All right, then finally you can see the endpoint group. Now endpoint group, why we have this slide? Because you will find that most important object type in ACI model represent a collection of similar endpoints which will share policies like security, VM, mobility, QoS, L4, L7 services, completely decoupled from the logical and physical topology. So all important things you are seeing here in the endpoint group, they can categorize as application endpoint. See a long list: application EPG, L2 EPG, L3 EPG, management EPG, UB inbound. Two types of EPG we have: regular or attribute based. Attribute based means suppose HR. So I have endpoint groups, they have the common name called HR. So I have 25 endpoint groups like that. It's like that. You have some common term or common name in between them. So you can have the attribute based endpoint group as well. Now again, if you go deeper on the ACI fabric and the structure, you'll find that okay, all these endpoint groups, they are mapped with the bridge domain, correct? So bridge domain, that means you are getting some common subnet. Web service HTTPS endpoints, they have this subnet. It's just for an example. And for HTTP endpoint, you have this subnet 10.10.10. Other is 10.10.10.11. Different endpoint, if you want to communicate, by default they will not. You need contract. Contract, you need to define subjects and the filter. Filters are nothing but the ACL entries. So here you can see contact group of subject, define a scope, global, tenant, AP, group of filter, unidirectional, bidirectional, that is the subject. Inside subject you can define the ACL entries. So these, suppose if you want to allow ICMP or say HTTP port 80 or HTTP port 443, so you have to create the ACL lines and you have to define who is the provider and who is the consumer. So for example, the provider is app, consumer is web. So that relation you have to create along with your ACL entries. So that was the thing that we have discussed so far. In continuing this or adding this, we have total 3 video for ACI, just that you understand ACI before doing the programming related to Ansible. And next module onwards, we have the programming related to Ansible to create various logical entities inside the ACI fabric. In this section, I'm going to show you that how you can create the VRF and the bridge domain inside the tenant. If you want more information, you can go to these URL, ACI VRF and ACI BD, and you can check other options as well related to VRF and the bridge domain. So before creating these VRF and BD, let's go to our Epic controller and verify that okay, we do not have any existing VRF and bridge domains. Alright, so you can see that recently we have created one tenant called ACI Lab Test, and that is there. If I go inside the networking, say VRF and the bridge domains, we don't have any existing VRF and bridge domains that we are going to create via our Ansible program. So let us go and log to the Ansible. We'll create the VRF bridge domain. We'll come back here and then we will verify that. We are inside the Ansible. In this case, let's create one directory and there we will store all the program. So the directory name, for example, VRF, and then we'll go to that directory and here we are going to create all the inventories, program, etc. So first of all, I want to create inventory. This time what I want, that instead of only the host name, I'll give the username and the password as well, because that is the standard way to write your program. So the name, the user and the password like this. Once I have this, I can go and exit. Next time, Next thing that I want to do is I want to create a variable that I will call inside the main function that we used to do in the other Nexus program. So I'll create, say, external variable dot yml here. So let's create the variable for the bridge domain and the VRF. First of all, for VRF, I'll go down and one space because I should maintain the label as well. What is the name of this VRF? So I can give, say, ACI lab underscore VRF. Then what is the description? So description is demo VRF, something like that. You can give any logical description. Then finally, what tenant it's belonging to. Tenant is, say, ACI lab test. This is my tenant name. So we are done with the VRF. Next, what I want to do, I want to create the BD variable. The name of the bridge domain, I can give, say, ACI lab BD and VRF. Here what I will do, I'll give, say, bridge domain 1. Maybe in future, if we want to create 2, 3, 4, 5, 6, we can create that. So name what I want to do here, I'll give the name, say, ACI lab BD1, for example. BD belongs to which VRF? So we have the VRF, the ACI lab VRF. This BD belongs to this VRF. That's great. Then what is the tenant? So tenant also we have, that is the ACI lab test. All right. So once we have the variable created, these variables I should call inside the main function. So let me write this and quit from here. Now I'm going to write my main function. So main function is, say, for example, bd vrf.yml. This is my main function. We'll start our playbook with the name. If I want, I can start with the name, or if I want, I can simply do this, say, connection is local. Then I can give the gather facts and all those things. So say gather facts, no variable files, because we have external variable that I can call here, and this is the external var that I have. So I can go to the program, that BD program that we have, and here the external var I can put like this. All right, so far it's okay, no problem on this. So connection, gather fact, variable name, everything is good. Now what I want to do here, I want to create a task. So let me go and create the task, and task will be, so what's the task I have? I have task name is a VRF first of all, or I can give VRF demo, something, any name you can give. Then inside that name, what I want to create ACI VRF. Remember, you can follow that link that we have discussed earlier. So there you will get more explanations about all these things. I'll go one level down, and this the VRF, because now I will give attributes related to VRF. So this VRF, what's the name of this VRF? So VRF name, this program will be called. Alright, so from external variable, it will fetch the VRF name. The name is ACI lab VRF, something like that. We can verify after the execution of program. So let's write the code. Then we have the description. All right, so what was the description? We have the description. The description also we can call here VRF dot description. Likewise, I will add all those things. Then the tenant, because this we are a part of tenant, so I can go and give VRF dot tenant, because VRF is my variable, and inside that variable I am calling the tenant name. All right, then we can give the state. State is what? Present. That is important. Then I can give the host. What host it is? Again, it will call the inventory that we have. That is say inventory underscore host name. That is the epic. Then I can give the username and the password. So user name and user. We have that username and the password. Then the password. So password, that also we have inside the variable that we have, the inside the inventory that we have. So let's just give this and close this. Finally, because we don't want to validate the certificate, this is something like my Ansible will skip some self-signed certificate. So validate the certs, that is false. Wow. So now you can see that long program means the ACI VRF has the VRF. We are calling the VRF variable, VRF and all those things. The state is present inside the label. So that is okay. That is good. Once we do up to this point, what we want to do next, that I want to create one more task inside that. That will be the bridge domain. Because we have the bridge domain as well, the name should be in the same label. All right, so now we can create the bridge domain. So this time, what is that? ACI bridge domain. And same way I'm going to write the program. So BD, what's the BD? This will be say BD dot name. Even you can replace the VRF with the BD. If you want to edit this quickly, you can do that. What's the VRF? So VRF will be BD, that is the variable dot VRF. That's 100% correct. Then what is the tenant? Tenant will be the same BD dot tenant, because BD is the variable we have. Then what other things we have? A state is say present. I want to do that. Then I can give the same username, password and the validate certificate that I have there. And that's it. We are done with the program. Now let me go and write this, and then I want to execute that. So I will go and execute that playbook. That name is BD and it is from inventory. Now if everything is correct, it will run that program and it will execute. If any label problem, because the program is 100% correct, or maybe some spelling mistake, that we can correct and then run the program. All right, let's see that what's the issue we have here. Connection local gather fed. The error appears to have been home Ansible VRF line 4 column 14, but maybe elsewhere in the file depending on the exact syntax problem. Here is the syntax, and the YAML scanner error is there. Now if you go here and you can see that label is there, but I haven't added the host as well. So let me go and add the host. So let's do this. So one by one we'll improve this. Whatever problems that we have, we'll try to remove. So host is Epic. Now let's see. Let's run this program one more time. Host Epic here, offloading. So still it has problem because the program that we have started here, that should start with name, correct? Because all the other programs we have started like that, and once you are giving the name, then you should check the labels as well. So I'll check the labels, no problem. Then the name, I will give the name, and the name is this is the playbook. So this is the playbook to create the BD and the VRF, correct? Now let's see. So one by one we are improving the program. Tasks here, and you can see that the offending line appears here. So now if you go here to the task, your task label should be the label of your program, correct? So rest, let's see. So you can see all these all these labels and the correction that you need to do. Name here. All this problem that we have at the moment, it's related to labels only. So let me correct all these labels, and then we'll execute this program. So now you can see I have corrected the labels. So below task I have this dash, and then name and ACI, and then all the labels, then name, ACI, all the labels. So now it seems okay, and let us run the playbook. So now you can see that okay, it is creating that task 1, that is the VRF demo, BD demo, missing requirements argument as host name. So one is okay, one is changed, one is failed. If I go here, if I check the username, so you can see the username is user password. Everything is okay, but you can see after a state, the host name is missing. So these things we need to take care. So let me quickly go and edit the state and the host name. So after a state, I have the host, and this program may be a good learning curve for us, because you can see step by step how you can check the errors, you can improve those errors, and then you can execute the program. So here clearly you can see that missing requirements argument is the host name. Run this playbook. Now 2, initially we have 1, so now okay 2, change also 2. Let us go to our Epic controller and verify it. So I am here inside the Epic controller, and now you can see that yes, I have the bridge domain ACI lab BD1 100%. Then I have one VRF, that is also 100%. It has been created with help of the Ansible program. Let's close here. In this section, I am going to show you that how you can create the contract with help of Ansible program. You can go and refer this particular link to create the contract. Now let's go directly to the Ansible. Inside that I will create one directly. Inside that I want to put this program. So let's directly create the contract. Here I am inside my Ansible. What I will do, I will create one directory, say cont. We'll go inside that directory. So we'll go inside the cont. Here I want to create all those programs. First of all, I will go and create the inventory the same way that we have done earlier. So the name is Epic, user is admin, and the password that we have is Cisco12345. Let's save this. Now I want to create my program for contract. So contract.yml. I'll go inside this. I will start my programming. So how we can create that program? First of all, give the name. What's the playbook name? So playbook is for contract. So I'll give is for creating the contracts. Alright, once we have this playbook, then obviously I'll go and give the host. For all the programs we have used the same type of structure. Then connection is local. Then gather the facts. No. Then I'll start the task, correct? So I'll go here and start the task. Let me create the task. And the task name, I'll give the name of the task is to create the contract, correct? Then we'll go inside the name, and from here onwards you can go to the link and you can have a look. So ACI contract. Inside ACI contract I'll give the name. So name is the item. Let me close that braces. Then tenant. So we have the tenant called ACI lab test, correct? Then the same thing like we have done earlier, the host. So host will be like this, inventory host name. Then I can give the username and the password. So username, and username is the user that we have, and then the password. So let me quickly give the password as well. Password is pass. Alright, so we are almost done. What I want to do here, that I want to do the validation of the certificate. So validate certs false, correct? So false, and then finally below the name I can give the with items, what items I have for the contract. So I have contract, say a web contract, then I have contract, say app contract, then I have contract, say DB contact, and that's it. Now what I can do, I can go here and write this. If everything is good and working, then I can run this program. So let us run this program. The playbook, that is YAML, and the input is inventory. Alright, so name playbook. Okay, so let's improve that. labels and all those things, and then we are going to run that program one more time. So I'll go here and remove this colon, and you can see how much case sensitive all these programs are. Okay, so we have syntax problem. Somewhere we have the undefined variable. Let's see where we have the undefined variable, and I can see here, you can see item, should be item, correct? So where it's that, the name here should be correct. So if you are writing this program like very fastly, then it may have some issues. Otherwise, it will go run and execute that program, and then your contract will be created like this. Let's verify this inside the Epic controller. So let me log in back to the controller, and we'll go to the tenant that we have. So we'll go to the tenant. Our tenant is ACI lab test. I can go to the security policies, contracts, and now you can see that I have app, DB, and web contact. So this is the way that we can create the contracts inside the tenant with help of our Ansible program. In this particular lab, we are going to create application profile and endpoint group. You can go and refer these links for application profile and the endpoint group. So let us go and log to our Ansible from where I want to create AP and the endpoint group. So here I am inside my Ansible. First of all, what I'll do, I'll create one directory, say end application profile, and then I'll move to that directory. From here I will define everything. So first of all, what I want to create, I want to create the inventory. Inside inventory, the same thing that we have done earlier, that the epic, what's the user and what's the password. So user is say admin, and the password is say Cisco 1 2 3 4 and 5. Alright, so once we have the inventory defined, then I'm going to create external variable .yaml because I want to define some variable. So let's define some variable for this. First of all, I have endpoint group EPG. EPG, say for example, name is web EPG. Then what's the bridge domain? Bridge domain, say I can give any name, say ACI lab. Earlier we have created this bridge domain, ACI lab BD1. Then we have the application profile. I can give say 3-tier architecture. We have web app and DB. So like that I can give say web app name. And then finally I have the tenant. So in our case the tenant name was ACI lab test, correct? So this is my variable. Once I create the external variable exvar, then I'll go and create the main function that will create the application profile and the bridge domains. Let's start our playbook. I'll go and give the name as a playbook. So this playbook is for creating say bridge domain. Then I need to do those things that mostly in all the programs we have done. Then host and then the connection. This connection is nothing but local. Then the gather facts. So gather facts are no. Alright, once I do up to this, then I'll call the variable. that is the variable files. The same we have done in the Nexus also, Nexus programming also. This is xvar.yml, correct? So now I have my programming body. After that, what I will do, I will create task, correct? So now this particular task is nothing but the name of this task is create application profile. Alright, so I will go below label of that name, and then this is ACI application profile. Then I will go here under that label, I'll define AP, and then we have to define all those things. So AP first, application profile, then inside which tenant this application profile is. So this is say under tenant, then what is the state? State is present only. Then what is the host name? Host name it will take from the inventory. So let's give that as well. Inventory host name. Let us close this. Then we should give the username and the password. So username is user, and then the password, that is the pass. Then we can go and give the validate cert that we used to do in the earlier programs. So validate certs false. Alright, so same way I need to create other task as well. This time the task is related to endpoint group. So create, I can do create EPG endpoint group, and here I have to give say ACI underscore EPG. Now you can see how easy that you need to define. So you go inside ACI, define AP, go inside ACI like this, define EPG. So definition of the programs are very easy in the Ansible. That's why it is widely adapted at the moment in the market. So the EPG, again the programming structure, EPG is also very easy. Then this EPG belongs to which bridge domain. So this again I can give BD, and they will call the functions that we have defined. So after this bridge domain I should give the AP, then I can give the tenant state. So after say EPG, bridge domain, and rest of the things actually I can copy and paste from the top because it is same. So after EPG I have bridge domain, after that I have application profile, after that I have tenant, then I have a straight, then the host name, then the username, then the password, then the validate certs. So now you can see that our program labels, everything seems to be correct. And what we can do, we can go and save this program, then we can run the playbook. So the playbook is nothing but main and then the inventory. If everything is correct, then it will go and run that program for us. So wow, command not found. Ansible playbook main. All right, so yeah, but still it was taking that if even the spelling was incorrect. Now you can see the here that okay, two task, okay, change, okay. So everything seems to be correct. Now what I'll do, I'll go to my Epic controller, and from there we can verify this. Okay, let's log out. Let me log into this controller, and once we log in, obviously we'll go inside the tenant. So let me go inside the tenants. Our tenant is ACI lab test. Even if I go to that tenant, all tenants, you can see that bridge domain, VRF, EPG. It is showing all those counters, correct? So if I go to the tenant, and if you go to the application profile, you can see I have this three-tier application profile. And then if I go to the EPG, I have web EPG. So now these guys have been created already. Health is 100%. I can go to the application profile, health is 100%. So this is the way that we can create the application profile and the endpoint group inside the ACI Fabric. Thanks guys, thanks for watching all these videos. Thanks for your time. Now we are going to do the automation with respect to our ACI, and obviously with help of Ansible. ACI supports different type of automation tools. Here you can see it support REST API, HTTP, ACI toolkits like Python modules, Cobra SDK, ARIA tool for converting XML or JSON to Python code. And finally, we have this Ansible Cisco modules. So we have so many modules supported for ACI with respect to Ansible that we can use and create different tasks or do different operations inside the ACI. So for example, in this particular lab, we have to create tenant. If you want to learn more about this particular module, you can go to this docs Ansible URL and you can check other options as well. So let me first log to the ACI, the Epic controller. From there, we'll see that how many existing tenants we have. Then we'll go to our Ansible. From there, we'll create the tenant, we'll run the program, and then we'll verify from the same Epic controller. So let me log to the Epic controller. So here I have my Epic controller, and you can see that tenant, inside tenant, I have common infra and management. So by default, you have these three tenants. Now what I will do that I'll create one tenant, say called ACI lab with respect to our programming, and you'll see that program as well. So step by step, we'll perform the task, we'll write our program, we'll execute our Ansible playbook, and again we'll come back here and then we'll verify that it has been created or not. So let us log into our Ansible. So what I want to do, first of all, I will create the inventory for my Epic controller. So I will give name, say Epic inventory. Name I will give Epic, that's it. Then let me write it. So I have my Epic inventory where I have Epic inside that. Now I will write my actual YAML program. So what I want to create tenant. So create the tenant, say YML, and like normal programming that we used to do so far, first of all I'll start the program, then I'll give the name of the playbook, that is a playbook to create. So I'll give some name here to create the tenant. Okay, then what is my host? The host is Epic, correct? And we have the connection, say local, the gather facts, the same thing that we have done in our all programs earlier, same thing you can follow. Then you need to create the task. What task I want? I want name. Say add a new tenant. Okay, now what I can do in the same label, you can refer the URL that I have shown you in the PPT. So I can go and give this function or give this program, say ACI tenant. Now what the host name? So I'll give the host name. What I want the host name for that. Say what I'm doing here, the ACI tenant inside the ACI Epic controller, whose host name is Epic. So my controller name is Epic. What's the username and password? I will give that. Then I will add the tenant like that. So let's see. Username, I know that username for that is admin. Let me give the password as well for my Epic controller. Say password is Cisco12345. Now here I will give the tenant. So the tenant is nothing but the say ACI lab for our testing. So this is the name of the tenant, and you can see I am following the same label. Otherwise, you know that it will throw an error. So description I will give say test purpose, something like that you can give. Alright. Then finally, what is the state it has? The state is present. And validation certificate. Why I want to give this validation certificate? Because what is happening that if you give, so let me type this command first, what I try to tell you. So first of all, what I want here is to give validation certs that is false, because EPIC controllers, they have their SSL certificates for validation, and if I give this command, so this should only be used for personally control self-signed certificate. Okay, so because I have my local Ansible and I want to execute the program to my local EPIC controller. So if I make this false, and the spelling should be correct, if I make this false, then it will not ask for certificate. Okay. Alright, so my Ansible will not validate the SSL certificate. This is the program. If everything is okay and correct, what I can do, the same thing that we used to do earlier. So that is the Ansible playbook, and that playbook is nothing but tenant.yaml, and then the input is epic inventory. Now if everything is correct, it will work and we'll get all supported and the correct messages. Add a new tenant. It tried to run that program and it has some issue, so it got failed. Let's correct that. So only thing that I can see here is that we have some issue in this particular command. It should be validate cert, and if you go back, you can see here that some error is there, unsupported parameter module inside the validation certification. So this was the unsupported one. After correcting, let's run that. Now you can see that it has been this tenant has been created. Now let me go to my Epic controller. Let's log into the Epic controller and verify that. So I am here to my Epic controller and I can see that yes, this ACI lab test has been created. Here also you can see on the top The health score is 100%. I can go click inside that. I can go inside that and I can verify also. So now we have successfully created our tenant, that is ACI lab test, with our program. So let's stop here.